I would like to introduce Dr. Danielle Boyce, ALS TDI's brand new principal investigator for real-world evidence.
Hi, thank you so much, and thanks for everyone for coming today. I was so honored to be asked to moderate this panel. As John mentioned, I am brand new to ALS TDI, although I've been working with ALS TDI for some time, but I'm really excited to learn from this panel of experts today. And so now I'm going to ask you, maybe we just start with Fernando and go down, to introduce yourself and explain your connection to the ALS space.
Thanks, Danielle, and thanks all for your attention. I think I've been looking forward to this panel the most out of this entire thing for the past few months. So I'm Fernando Vieira. I'm the CEO and the Chief Science Officer at ALS TDI. I've been working in ALS research for 23 years, all of it at ALS TDI. Most of my time, the early years, were doing the work that Theo Hatzapetros described, a lot of preclinical drug testing in animal models. And as ALS TDI has evolved, the type of research that I've been involved in has gotten to change and grow too. Along with that, I did also lose my best friend to ALS. He had SOD1 mediated ALS. So it is definitely a personal endeavor. So I'm connected to ALS that way. Thanks.
So good morning. My name is Paul Wright. I work for a company called LifeArc based in the United Kingdom. We are a self-funded, not-for-profit medical research organization. So unlike a number of other not-for-profits, our money comes from drugs or medicines that have made it to market, mainly antibodies. We have 5 main areas of focus, one of which, of course, is motor neuron disease, or ALS as it's referred to over here. I've worked in the field for about 22 years, so my PhD was focused on trying to discover ways in which we can affect protein aggregation in motor neuron disease. And then I worked as a postdoc over here in the US with Bob Brown at Harvard, and then at UMass also in MND. So yeah, it's great to be here today and looking forward to taking part in this panel.
Thank you. I'm Sharon Hesterly. I'm the Chief Research Officer at the Muscular Dystrophy Association. I've been in the neuromuscular disease space for about 25 years now. And I think maybe some people aren't aware that MDA covers ALS research because it's not in our name. But we were actually the first organization to include ALS in our program because Eleanor Gehrig asked Jerry Lewis to do it in the 1950s. So we have a long history in the space. We have a long history of collaboration with ALS TDI. So I'm happy to be back here and talking to all of you. My background's in neuroscience and developmental neuroscience. So I'll pass it on.
Thanks. Hello. My name is Bernie Zimmert. As you can tell, ALS has impacted my speech. So I really appreciate your patience with me today. Beyond being impatient, I've spent my career in healthcare innovation. So when I was diagnosed about 5 years ago, I've been looking for ways to bring that skill set and hopefully make a contribution. As part of that, I am currently working with the team on a research effort called Project Mosaic. As you've seen this morning, disease models are really foundational to good drug discovery. And therefore, what we are trying to do with Project Mosaic is to accelerate the R&D into sporadic ALS disease models. And it is our hope that if we can bring those to market faster, that will help to improve the ALS pipeline success rate. Thank you.
And I'm Mehreen Ziprich. I'm Bernie's wife and here to help.
Thank you all so much. And I'm sure our audience will agree that our panel has a rich and diverse experience in this field. And so that brings me to my first question. Over the last 25 years, or as far back as you've been following this field, how has our understanding of ALS evolved? Would anyone like to take that?
I'm happy to start. Maybe I've been in the field the longest. I think there are a couple of things that have really stood out to me over that time period. And the first was a sort of general appreciation for the role of inflammation in ALS. And it seems so ubiquitous now that everybody appreciates that there is some kind of inflammation and that there are different cell types involved in the brain. It's not just motor neurons. But when I went to my first ALS meeting, the only presentation I heard about inflammation was from Stan Appel, and everybody was giving him the side eye. Like, where is this guy coming from? And now we really understand that it's not just about degeneration. With degeneration comes inflammation. The inflammation is part of the problem, and it's probably a big part of the problem. So I'd say that's one thing. And one other thing I will mention too is, I forgot my second thing. Let me hand it off to somebody else. I've said enough.
So I think for me, it's really been the role that genetics has played in ALS as the years have gone on. Fernando's graph earlier showed that 20 years ago we had SOD1 and that was about it, and now we have 30, 40 genes, and really I think we're getting close to the point where pretty much we're going to believe that all ALS comes from genetics in some way. Maybe not in a classic, you have a gene, you get disease, but it's going to affect the rate of progression, it's going to affect your risk. And so genetics will drive all that. And we have this really complex mosaic of genes at the moment, which we don't really know how they all slot together. And that's a challenge as the field goes forward. But understanding the genetics, understanding these kind of causes, and we're beginning to unpick the puzzle rather that kind of complex genetics.
Excellent. Anyone else? Bernie?
I've only been involved in the field for about 5 years. But even in those 5 years, it has been remarkable to see the progress that we are making. Building on Paul's point, I think that two things that stand out. One is the role of TDP 43, and the ways that it contributes to the disease process, and possibly maybe represents a common choke point. And the other big development, as we saw this morning, is that even 5 years ago, we were only talking about the promise of big data, and now we are beginning to see the payoff. Not only in genomics, but in terms of epigenetics, and proteomics as well.
And I'll just echo what all of our panelists have said, right? We have a much richer understanding. When I got into the field in 2001, I remember excitotoxicity. Glutamate excitotoxicity was the target space, maybe oxidative stress, and a little bit. I remember reading about, mitochondrial permeable transition pore. Those were like the three things that I was reading about back then. And now there's so much more. Like Sharon said, immune dysregulation, this concept of non-cell autonomy, it's not just the neuron. And this whole arc where we've, pun intended, arc, actually unintended. There's a lot of arc here, actually,
Yeah.
life arc too. Where just the introduction of this idea of the RNA binding proteins, TDP43, FUS, HNRNP, all of it, like there's a whole constellation of these things that seem to be involved. We just know so much more. Now, that has also made it feel kind of daunting. It's like, oh, wow, I don't have to just know one thing. I kind of have to know a million things. But there's just a lot of opportunity in that. It's just a space with a lot more opportunity for discovery now.
So I'm also wondering about the role of nonprofits in this research, and how has it evolved during this time? And Sharon, would you like to start with that? That might be something that you can comment on.
Yeah, so I think the clear thing I've seen is, first of all, I think nonprofits have had a really significant role in moving the field forward, raising awareness, in advocacy, and just pushing and pushing and pushing all the time. And the changes that I've seen, and probably everyone will agree, is we see organizations being less passive in how we fund things and how we do things. It's very much, and ALS TDI is the epitome of this, a top-down approach, where instead of waiting for things to come out externally, you're actually setting strategy and deciding where you want to put your funding proactively and what you want to follow. So we've seen a lot more top-down initiatives.
I mean, another really important thing about not-for-profits is the amount of extra money that they raise. I mean, certainly, again, over here, obviously you have Act for ALS and things. In the UK, not-for-profits lobbied our government, and the government gave tens of millions of pounds to M&D ALS research. So there's a role in taking that amount of money not-for-profits have, making it a lot bigger, leveraging that fund so we can do more research, do more good things. And what that also enables us to do is that not-for-profits play a really important role in establishing training in the next generation of scientists. So ECRs are coming from PhDs and other training programs. These are often funded by not-for-profits. So there's creating that sustainability in the field, which other organizations don't necessarily fulfill. The last thing, which I think is super important for not-for-profits, and we touched upon ARC and some of your other resources, is making tools available for the field. So big pharma and other biotech aren't necessarily going to provide those tools and those resources. Same for academia often. So not-for-profits fill this role, which enables others to do great science as well.
If I could, I think that we owe a big debt of gratitude to all the nonprofits that have really helped to pave the way. That said, though, as we look into the future, a, 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 a big opportunity, I think, is that we now have so many really great insights from academia, and 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 it is still taking a a really long time to get a lot of those innovations from academia into industry. So so one thing that we are trying to do with Project Mosaic, for example, and that I would love to see more nonprofits begin to do is to really think about how we can how we can accelerate the diffusion of innovation faster, and and I know that Paul, this is one thing that LifeArc is really focused on. Yeah.
Sure. Yeah. I mean, absolutely. I mean, I think the way in which we can bring a more cohesive environment together is really important. This is a hard challenge, so we shouldn't be duplicating efforts. We should be trying to find ways in which we can ensure that we're maximizing the effort and maximizing our energy, and bringing people together. I think is a huge role that not-for-profits can do in a way that others can't. Being that honest broker in the system is a real key and pivotal way that I think all kind of not-for-profits can kind of interact.
Yeah, I want to follow up on Bernie's point and then add another point as well. Yeah, ALS TDI was founded by Jamie Haywood and the Haywood family to kind of accelerate that, right? So recognizing that there was a lot of incredible research being done in the academic space, but it wasn't necessarily getting translated into solutions for patients. So we've existed in that ethos, and we're glad to see others are working in the space too to try to make progress. And it's exciting to see what all of your organizations are doing to accelerate that. I wanted to make one more point on the impact of nonprofits and ALS. It's bringing people with ALS into the space and the research space, the solution space. It's been incredible. Like it's in the nonprofit space that's happened, right? Where we've seen both people with ALS leading organizations, creating Project Mosaic, Augie's Quest, Augie Nieto starting Augie's Quest and supporting ALS TDI, Stephen Haywood as part of ALS TDI, and my friend Sean Scott, who was a leader here living with ALS and his mom had the disease. That's all happened in the nonprofit space, and it's people with the disease who really end up bringing that sense of urgency that's been critical. So I just wanted to make that point as well.
So you kind of all touched on my two next questions. So one is how collaboration and openness and competition within the ALS research community has changed over time. And it sounds like the nonprofit groups that, have really pushed that forward. And then the other, and I don't have to ask Bernie this, what role the patient community has played in advancing ALS research. I feel like we have the example right here. But I would kind of like to talk about that role, that how we have become more open and we've been more collaborative, and how the patient community and nonprofits have played a part in all that.
Um, 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 well, I, I, I really have to give TDI a lot of credit here. I think that as Fernando said, that they have really been modeling this. One of the one of the first conversations I had, actually, after I was diagnosed and looking for ways to get involved, was actually with Steve Perrin and Fernando, and I am still so appreciative of that openness, and 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 the way that that you really are able to put patients at the center, and and as you all know, this is a really difficult disease. So having that foundation to build on, I think is incredibly helpful for patients to then be able to advocate and contribute to research more effectively.
Sure.
So I think we've seen a lot of collaboration in this space. It's really increased quite a bit over the years. And what I see, certainly our approach to it is that this is a pretty crowded space. There's a lot of organizations in the space. People are doing a lot of interesting things. So we kind of approach it from, where are the gaps? We don't want to repeat something that someone else is already doing. So if there's something we feel strongly about, we might collaborate with another group or offer to collaborate. I see this just happening much more actively, and I think it's only good for the field. A little bit of competition is probably healthy. That can drive things along as long as you're not recreating the wheel and you're moving things forward. So I definitely have seen a change over the years.
I mean, two things just to follow up on, because a lot of the good stuff's been said already in this conversation. But realistically, we need to have collaboration, and both international collaboration, to really get to the numbers we need to. If we think about genetics, we're now at relatively rare genetic variants. We need to be looking across broad populations to understand where they're coming from. All these incredible initiatives when we're following people and we're looking for those who convert to ALS. Well, those events are still relatively rare in our resources, so we need to be doing that across international collaboration. So, we need to play the numbers games, and that comes from collaboration. The other thing to touch upon is that sense of community that we need to enforce as well. So we need to have expertise from drug companies, from academics, from scientists, from patients, from regulators. All these groups need to come together because this is a complex problem. It's going to take multiple stakeholders to deliver success. And I think that's the other really important point about collaboration.
Yeah, that ecosystem is so important. And I just wanted, I'm going to be talking about this afternoon, but I have seen open science tools really boom in my 30-year data science career, where people are now using Python and R and sharing on GitHub. And again, as well, I'll be talking about this afternoon, but I feel like that has had a big contribution. So even if you're working on something separate, you can share your code with one another. Fernando?
Yeah. One of the biggest ways that I've seen, there's definitely much more collaboration, and part of it is a result of the types of projects that are being done, right? So a lot of big data projects, and I'm seeing a lot more data sharing, a lot of openness in data sharing, which is incredible. I think I want to make maybe a semi-controversial point, that sometimes redundancy is okay. Right? Because in science, we're looking for a lot of replication, right? And you can do replication in series where one person finishes a study, then another person tries to replicate it and see if it happens again. Or you can be doing it in parallel, right? And so if you end up with two groups finding the same result around the same time by doing it slightly different ways, that gives you increasing confidence in that particular finding. So I think you definitely don't want too much redundancy. You definitely want to make sure you handle your resources in a domain where we do have limited resources. But when time is the most important thing, not money, and in ALS that's the case, I think it's okay to have a few things running in parallel.
Yeah, and I know a lot of our friends in the patient advocacy community, many of whom are here, have posters at the international conference, right? And so I think we understand how we can share our work and share our successes and how collaborative and communicative we are with one another. So we don't all work in a vacuum. I find the ALS community to be quite collaborative, sharing our science and disseminating our findings. We could always do better at that, and we can always communicate it better to all audiences, I feel. But that said, I think we're really striving toward moving toward that direction, especially with the inclusion of people with lived experience. I find that has made in all aspects, in my view, for it to be a more collaborative community. So here's a juicy question. What are the most pressing unanswered questions in ALS today? Who wants to take that one?
I'll start
Okay.
that one. So I think one of the big questions still for me is, what's happening to get us to that point where we start ALS? What leads to that point in the body? We know it's a motor neuron degenerating, but what's the sequence of scientific events that gets to that point? And therefore, what can we measure? What can we understand that's happening before that? Because once we know those earlier events, we can begin treating people earlier, and we have a better chance of finding successful therapeutics. If you think of things like Alzheimer's, it's all about people with mild cognitive impairment now, Parkinson's, sleep disturbances. Once we understand those pre-symptomatic pieces of MND, ALS, we'll be able to really start having, I think, a better chance of successful treatments. But there's still so much biology we just don't understand before we get to that point. Often by the time someone's been to see their physician or their doctor, we know there's a lot of motor neuron damage already. MND as others have said to me before, it's insidious in nature. It's slow, and then suddenly you're at this point where it's very late, and it takes a long time to get diagnosed. So, if we can understand the biology earlier, I think that gives us a much better chance of finding successful treatments.
Anyone else like to take that? Bernie?
Sure. Yeah. One of the big questions I think is whether that is whether we can slow or even reverse progression by focusing on common choke points like CDP 43 or whether we really need much more targeted approaches like Jefferson demonstrates. Yeah.
Yeah, and I would just agree completely that the biggest challenge, I think, partly is understanding, especially in sporadic ALS, what starts the disease. And we're learning a lot from the genetic forms. But what's clear is just like different genes that have very different roles can lead to ALS, there's no reason to think it's going to be one cause for sporadic ALS either. So it's understanding, are there common pathways that we can approach, or is this a series of very different diseases that look kind of the same at the end?
I've been in the epilepsy space for a long time, and we found in rare epilepsies this to be the case. When 10 years ago there were a handful of culprits, and now it's just exploded, and we can develop targeted therapies. And many of the patient groups even think of themselves almost as separate diseases in a way, with shared symptoms.
So that I actually think that's another obstacle we need to think about. You talk about separate diseases. Is once we get to the point where we have treatments and likely advanced therapeutics, gene therapies, we need to make sure we're ready to get those drugs to people. We need to make sure our economics are right. And obviously you have a very different system in the US than we have in Europe. But there's been decisions made by our regulators in Europe, which is sort of on a different disease, for example. And that's going to be a big challenge. These are going to be expensive medicines that people might be on for very long periods of time. So we need to make sure we're ready, and we need to make sure we're able to get these exciting breakthroughs to people when they need them.
I agree with everything that I've heard, and a strong case could be made for any of those. So I'm going to just pick a different one as a devil's advocate. Biomarkers, right? So being able to measure that a drug works reliably in the clinic, and having an interpretable result in a shorter cycle time. So being able to know quickly so that you can move on and try a new thing. So that's another juicy possible point that one could make.
For sure. And this is what we hear again and again from, not to keep bringing back the patient community, but that's what I hear from them also, the biomarkers, the progression, the heterogeneity, the sporadic. So what are the key challenges or obstacles, kind of different from unanswered questions? What are some challenges or obstacles just in the science of doing this work overall?
So again, I think a big one really is about how we measure disease progression. That does come back to biomarkers. Fernando just touched upon using biomarkers in trials. So in the UK, we're just about to launch a trial called Experts, which uses NFL as a way to measure disease. And what this means is that we can test drugs in a quicker way, and we can get a qualitative answer based on the biomarker. Now, this isn't going to necessarily tell us if the drug works, but it does mean we can prioritize that drug, and we can triage treatments better before we go into a full-stage clinical trial. That means drug development is not only quicker, but again, I think gives a better chance of finding success. So I think that's a really interesting platform where we can measure something qualitatively using biomarkers, which are, again, a hugely important area which we need to do a better job of.
Um, 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 if I could, Daniel, maybe this is my background with an MBA. And and I don't want to discount the scientific challenges, but 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 I often think that we um, we don't have a science problem in ALS per se. We we have a management of science challenge, and 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 what I mean is we we don't have a lack of really incredible people doing doing really incredible research. One thing that I would like to see more of, though, more attention on, is how can we put the pieces together faster? How can we, in particular, improve and accelerate collaboration between academia and industry? Because we can have the most brilliant breakthroughs in a academic lab, but to really benefit patients on scale, we have to get those into industry faster.
Yeah, I agree that translational piece is really important. And also, I think diagnostics, which we've touched on before, but if we can just diagnose people earlier, we know from animal studies that routinely, the earlier you treat, the better the outcome. And so if we could just back that window up by 6 months even, we might have the ability to intervene more effectively in the disease process. And I feel like that's solvable, especially with artificial intelligence and the things that we can do with big data. I mean, Google knows when women are pregnant before they know themselves, just based on search history. And there've got to be some ways to mine that kind of data. It sounds like a massive invasion of privacy, but perhaps.
Fernando, would you like to comment on that?
I would. This morning, if you were watching my presentation, I have this slide, which is the drug development pipeline, right? Like of the different steps that have to go through. And we've talked about how ALS might be more than one thing. And it takes a long time to develop a drug for a disease. And if we're talking about ALS being actually a syndrome or a mosaic of multiple conditions, like all of those potential therapeutics kind of have to run through all of those steps. And you really do need to be running that in parallel if you want to have an impact on a lot of people sooner. And so for me, to be blunt, it's a resource thing. We need more resources to be able to run more good quality therapeutics through that pipeline faster.
There's also an element, though, of get into a consensus about what the right resources are. I totally agree. With more, you can do more with more, right? And without getting into too many European metaphors, it's about shots on goal, right? That gives you more chance of scoring. But ultimately, the field, bringing the field together, and we talked about openness coming together, reaching a consensus about what the best models are. Do we have confidence? And we don't know the answers to these yet, but enabling us to have a more efficient pipeline, and we burn it, and so that's on translation. If we're able to reach a point where we're de-risking these things before they make it to industry, it means that barrier is much lower. It gives people more chance, more investment goes in because the risk is lower. And so reaching that consensus and having a system where we're able to say, we've ticked this box, we've ticked that box, we believe this model, we believe this model, we know our drug gets to where it needs to go, we know it's there for the right amount of time, we know it's hitting the target it's meant to hit. We're able to build up this menu of, yes, we've done this in the translational space, therefore the investment in that clinical study is much lower, and that increases the amount of investment that goes in. So it's all a kind of circular point about necessarily doing the right things at the right time, as well as doing more of it as well.
Yeah. So, I've been, because I'm a data analyst, I've been doing a thematic analysis in real time, but we can throw it to the audience for questions right now, and then maybe summarize. And I'm sorry, I have my back to everyone.
Just further to what you mentioned earlier about if you discover the disease earlier, better chance of success for stopping it. What % of research that's going on now is actually on the very front end of trying to determine if someone's going to be getting ALS versus actually going through and making the drugs and to try and stop ALS? Because seems like if it's easier to stop early, shouldn't there be a lot of research and funding on that part of the sector versus the later part of the condition?
So would anybody like to take that? And can we kind of summarize the question? Go ahead. Sorry.
Sure. Yeah. So the question was, if the outcomes are likely to be better if we can diagnose earlier, what percentage of research is actually focused on this very important question? And I think the answer to that is that a lot of the biomarker research, and there is a lot of biomarker research, some of these biomarkers might also be used diagnostically. And there is a lot of work around the familial forms to look at that. For example, there's an ongoing study looking at people who have the SOD1 mutation to really understand when they go from symptomatic to pre-symptomatic to symptomatic. And they're also enrolled in a study with tofersen. So I think those kinds of things help us understand, but the overall percentage, it probably doesn't reflect the importance of the question.
Yeah, I would agree with everything Sharon had said. Certainly looking at biomarkers, blood-based biomarkers in people with mutations before, you hope they never actually develop the disease, but trying to capture, if they do, what might be measurable in those so that you could try to prevent. Another thing that we're doing is we have a digital biomarker program that Alan Primaseri described, where we're looking at accelerometer data, measuring people's ability to move and their voice recordings. And one of the points I made in my morning talk is that different symptoms manifest at different times in different people. So a person who might have symptoms early in their voice, they might not really be very affected in their limbs. So one of the things that we can do is look at what's happening in their limbs before they have detectable symptoms there to see if there's an accelerometer signal that tells us that onset is coming there. And you can do the inverse. For people who have no bulbar symptoms, but they come in with limb onset, we can look in their voice recording. So we're doing that. I know Everything ALS is another organization that's been looking at those types of data as well. But really, to Sharon's point, the importance of it probably isn't reflected by the investment right now.
And I will just add, if there's a minute, too. Sure. I think the challenge is because ALS is a rare disease, and a lot of the type of screening we're talking about with biomarkers and other things aren't things that are going to happen routinely if you come in with what you think is carpal tunnel syndrome. They're not going to draw CSF fluid.
Mhm.
And so the key is, are there things that are less invasive, less expensive, easier to use as a screening tool for something that is effectively a very rare disease? Because from a public health standpoint, it's hard to get governments and other places to pay for screening for a very rare disease. And that's sort of one of the challenges.
So, are you taking any more questions, or do we have any more? Can we do one more? Okay, one more question. Sorry, I can't see if they're telling me. I'm blinded.
Hello, I'm Sean Sarbacher. I am a person living with ALS, and all the science stuff is fantastic. But for looking around the room, there's quite the ALS here today. If you could, please tell us, people living with ALS, what you see as the biggest impact things that you can do, that the community can do to, give us the best fighting chance in dealing with this disease.
Sure. I would say two things. Number one, as we are learning more about the disease and and the role of GDP 43 in it. It seems like a very promising target, and and there is more and more drug development happening around it. In fact, just yesterday, for example, I met with a company that is doing some really incredible research on this. But that leads me to my second point, is that one of the reasons that we are organizing participants like is that this is see me such a heterogeneous disease that until we have disease models that reflect the full mosaic of the condition, I worry that we will continue to have a lot more reliable type experiences. That said, though, what gives me hope is that even relative to 5 years ago, this stuff is not theoretical anymore. There are a lot of companies working on the on the GDP for the research and others and these better disease models have been demonstrated. So in many ways, the task before us is to try to put these pieces together as 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 fast as possible, so, so that we can help patients like you.
Thank you so much, Bernie, for those wise words, and to our entire panel. And I just want to pull out a couple of quotes. We're wrapping it up. Just a couple of quotes. I've been taking notes, as you can see. But one thing that Bernie said that really struck me is that we don't have a lack of incredible people doing incredible research. And so thinking about the last 25 years and how we're kind of poised on the brink of these discoveries, there's no shortage. But that you also pointed out, Bernie, that we need to be collaborative. And then something Fernando said this morning struck me. If we keep pushing, that's our job. So thank you very much for this great discussion.